Okay, so we are going to be working with section 4.3 material, primarily working with graphs with intercepts. So we're going to start with our definition of the two intercepts that we are going to be working with, how we find them, and then how we can work with them and everything moving forward. So we have two primary intercepts, the x-intercept and the y-intercept. Our definition of these, the x-intercept, is the point where the graph crosses the x-axis. This point is always going to have a y value of 0, because again, it's where it's crossing the x-axis. And the y value at the x-axis is always going to be 0. The x value could be any number. It could be positive, negative, 0, a fraction, a decimal, whatever it may be. The y-intercept, very similar to that, it's the point where the graph crosses the y-axis. And along the y-axis, the x value is always going to be 0, and we would then be determining what the y value is. So these parts right here, knowing what the x-intercept is always going to have, what the y-intercept is always going to have, this is very, very, very important. So when we get to determining intercepts, either graphically or algebraically, we are already going to be given half of our answer. We need to remember which one already has which value. So the x-intercept already knows the y value. The y-intercept already knows the x value. Or you can think of it as the x-intercept, I'm looking for an x. The y-intercept, I'm looking for a y. Either way you want to look at that. So all linear equations that we are working with, except for horizontal lines and vertical lines, will always have both an x and a y-intercept. So if you were looking at an equation and you notice, okay, this thing is not a horizontal line, this thing is not a vertical line, you are guaranteed to always be able to find an x and a y-intercept. You'll always be able to find it. The numbers might be gross. You might get some weird decimals showing up. You might get some horrible fractions showing up in there. It might be positives or negatives. Doesn't matter. You can still find the x and y intercepts. So how we can go through and determine these intercepts graphically and then algebraically. So we have some examples that are down here, and I'll go through and I'll show you guys what these will look like graphically, and then we'll go through and actually solve for them algebraically as well, so we can get a visual of what these intercepts actually look like. So if we are asked to determine the intercepts graphically, more often than not, we can do this just by inspection. We'll be given a graph, we'll be looking at that, and we can just say, okay, where does it cross the x-axis? Right here, there's the point. Where does it cross the y-axis? Right here, there's the point. And that's all that we would need to do at that point in time. We need to look at that and then just fill in the missing information in that ordered pair. So this is how we go through it algebraically. On the homework or on the test, I am well aware of asking you guys to show your work and everything, but if there's a problem on there where you're given a graph and you're asked to identify the x-intercepts and y-intercepts, and you just put in the answer, I'm well aware that that's all that you can really do, because you can do it by inspection, and you're good to go on that front. I'd be well aware of that, and I would not be expecting you guys to do a bunch of extra needless work when I'm requesting you to do that by inspection. So I just want to clarify that part right now. If we were to go through and find these intercepts algebraically, we determine which one we are solving for, and then plug in 0 for that necessary variable. So for instance, if we have been given an equation, and first we're going to solve for the x-intercept, which is fine, I'm going to plug 0 in for my y variable, and then solve for x. Vice versa, if I'm going to be solving for my y-intercept, I need to plug in 0 in for my x variable, and then solve for y. The big part that makes this very difficult for people is not making it abundantly clear for themselves, what am I solving for? Am I solving for the x-intercept, the y-intercept? People do not label their work, and then they get answers and they don't know where to put the answers, and it goes in the wrong place. Once we have everything plugged in, we're just going to solve the equation for the remaining variable. Everything we've learned up to this point in time is what we're going to be using to do that. And then, this is another part that gets people, write your answer as an ordered pair. If I am asking for the x-intercept or the y-intercept, that is asking for a specific point, an ordered pair, so you need to list the x and the y value. If you are solving for the x-intercept and you just leave your answer as x equals 3, I don't know if that's a point, if that is an x, I mean, it's an x value, but I don't know if that's an answer to a different problem or whatnot. You are being asked for an ordered pair. You need to give your answer as an ordered pair. You will lose points if you do not do that. So that goes for all of these. So you find your answer, x equals something, y equals something. Your last step is to rewrite it as an ordered pair. And we'll go through examples of that down below here, okay, when we go through it algebraically. So first and foremost, I want to go through how we would identify and determine the intercepts of these things graphically. So I'm going to reference these 4 equations. We'll see what the program is going to allow me to, how it's going to allow me to plug things in, but we'll work with it from here. So we'll work with at least the first one. I know this one will work. So I'm going to jump us over to a website. It's very handy to use for this sort of thing. Okay. So this is the website GeoGebra. It's a free website. You guys are more than welcome to access and use this for whatever it is that you'd like to be graphing. There's great geometry tools in here. Free product, free website. You're welcome to use whenever you see fit, as you do see fit. So off to the side over here, we're going to plug in our first equation that we were given. And that equation was y equals 5x minus 35. So I'm just going to be plugging that in. Y equals 5x minus 35. So now we kind of see our graph is showing up over here. I'm going to zoom us out a little bit and readjust this thing ever so slightly. Okay. So now we are looking for, all right, where are our intercepts showing up? The x-intercept and the y-intercept. Again, our x-intercept is our horizontal one. Our y-intercept is our vertical one. So if we're doing this by inspection, saying, all right, let's take a look at our y-axis first. I'm seeing, where does this graph cross the y-axis? We're seeing it does it right down here. Now I'm going to zoom in on this a little bit to see, is this an exact point that I have in here? And it looks like, yes, it's crossing directly at this point right down here. So my y-intercept is going to be at 0. I'm not moving left or right at all. Let's go at the point 0, 35. Because again, the point that's at here is 35 in our negative direction. So our y-intercept is going to be 0, negative 35. And again, we just take a look at it, and bam, we have our answer. No calculations needed. If we are looking for our x-intercept, we're going to go up here and see, all right, where does this thing cross the x-axis? Again, looking at our x-axis here, so, okay, it crosses at this point, and it looks like, let's zoom in a little bit, it looks like it is crossing directly at that 7, which is good. It's a nice whole number there. So our x-intercept is going to be the point 7, 0. We're moving 7 in the positive direction, and then we are not moving vertically at all. We're just staying right there. So we could be given, again, any number of graphs. This one's a bit of an extreme one because the 2 points are so far away from each other. But the idea holds true. We would be given a graph of some kind. And if they say determine the x and y intercepts by inspection, you're just looking for where it crosses the y-axis and where it crosses the x-axis. Now, the part that some people will do is they will get heavily reliant on graphing these things and then, excuse me, and then they will only look at the graph and then just pick an answer from there. Nothing inherently wrong with that until we start getting to situations where, and I'm going to make a slight adjustment to this. Let's say this is 31. And now if we take a look at our x-intercept, we say, all right, what is that point? Where does it intersect at? And kind of a nice one here in this instance, but if we were to zoom out and say, okay, where is this point that it intersects at? Well, it looks like it's, partway between 6 and 6.5, maybe it's 6.3, 6.2, 6.25. We'd have to approximate it, and we can't just look at it and have a direct 100% value at the end there. So this is an instance where we may want to then go in and solve for it algebraically if we can't look at the graph and inherently find an answer at that point in time. Okay? So that is one of the pitfalls of solving these things graphically, is if you can't see a direct whole number answer in there, it's not necessarily the safest of ideas to try and estimate that just by looking at it. That's where we'd get the instance of where we want to go by solving these things algebraically, which is what we're going to go do right now. So I'm going to jump us over to our whiteboard. And we're going to go through and solve a couple of these things for the x and y intercepts algebraically. We'll go through probably, 2, maybe 3 of these things. Again, I do want to get through this material and then get us onto 4.4 as well. So we're going to find our intercepts. So our first equation that we're working with is the one that we just looked at graphically, but now we're going to do it algebraically. Oops, minus 35. So again, when you are going through these, I think the process to solve these is pretty straightforward if you have your work organized. So going through this, we need to find the x and the y intercepts. This is not a horizontal line. This is not a vertical line, which means I can find both of those points. So I just need to pick which point I want to start with and then solve for it. Doesn't matter which one you start with, you just got to pick one. I'm going to start with the y-intercept. So label that for yourself, the y-intercept. The y-intercept, we always start with knowing the x value to be 0, and we are solving for the y value. So for me, I like writing in y-int, x is 0, and I'm going to leave the right part blank. Now directly below this, I'm going to write in my general equation, and then plug in the value that I already know. I know my x value to be 0, so I'm just going to plug that in. Parenthesis there. And now I'm going to solve for y. So 5 times 0 is 0. 0 minus 35 is going to give me negative 35. So I have my y value to be negative 35. And again, when you are asked to give the x and the y intercepts, that means you are being asked to have an ordered pair as your final answer, which means at this point in time down here, if you're thinking, oh, I'm done. No, you're not. You need to go and plug that negative 35 back up into an ordered pair we have up here. So again, this is why I like doing this, is it keeps the everything all right, neat and organized for myself. I know what I'm solving for. My answer is ready to go right there. Done. And now I'm doing the same thing with the x-intercept. Except for the x-intercept, I know the y value to be 0 based on our notes, and I'm solving for x. So again, start with the general equation. Substitute what we know. I know my y value is 0. And now I'm solving for x. So I want to get that variable term all by itself, so I'm adding 35 to both sides. Divide both sides by 5. And I'm getting that x is equal to 7. So again, found an x value. Fantastic. You need to put that back up in an ordered pair. If you do not do that, I will be taking points off because you are asked for an ordered pair, not a single valued answer. But that's our process for algebraically finding the x and the y intercepts of these linear equations. So we're going to go through another one. It's kind of a funkier looking one, but again, as a generality, that is the process. Doesn't matter how nice the original equation looks, how ugly it looks, how displaced and weird the variables are, doesn't matter. You're doing the exact same thing every single time. So I'm going to go with, because I do want to be able to move on to our next set of stuff, I'm going to go with, we'll go with example 4. It's kind of one of the grosser ones of these. So example 4 from our notes is giving us 3x minus 2y equals 24. Okay? And again, we are solving for the x and the y intercept. So just like we did previously, I'm going to tell myself, okay, which one are you going to solve for first? Solve for the x-intercept. I know the y value of the x-intercept to always be 0. And I'm going to solve for y, or solve for x, I should say. So writing out my original equation. There we go. And then plugging in what I know my y value to be 0. And now I'm solving for x. So I have 3x equals 24. 2 times 0 is just going to be 0. Divide both sides by 3. Oops. I'm getting x is equal to 8. So great, I've got that. And again, I have to plug that in to an ordered pair. Now I've got my final answer. For my x-intercept, at least. And then we're doing the exact same thing for the y-intercept. I'm hoping everyone is seeing that this is becoming, oops. There we go. This is a very mechanical process, this. It can only get so complex in terms of how we set it up and solve it. So again, I've been given an x value. I know my x value to be 0. I'm substituting that into my equation. 3 times 0 is just going to be 0. So I get negative 2y equals 24. Divide both sides by negative 2. Again, that y is equal to negative 12. So I have my y value, and I just plug that into my ordered pair. Ugh, there's 12. And now I have my x-intercept, I have my y-intercept, and I'm done. Can't do anything else from there. So again, with all of these, and we are solving for our x and y-intercept, it does not matter, if we're doing it algebraically at least, it does not matter what our starting equation looks like. It can be kind of our standard, our more common form that we're used to seeing. That's fine, doing the exact same process. We could have something different like this. You're doing the exact same process. We could have decimals in here. We could have fractions in here, positives, negatives, whatever. The process is the exact same thing. The numbers will be different, but again, the process is the exact same. Not much is changing on that front. Okay? Not really much of anything. So this is how we would go through and determine the intercepts algebraically. So we'll jump us back over to our notes. So we have a couple other examples if you guys want to go through those on your own. But again, we're doing the exact same thing that we just did with examples 4 and 1. Now, moving on, we're working with graphing with these intercepts. So this is expanding on the stuff that we did with the 4.1 and 4.2 material. Remember, to graph any kind of linear equation, we need 2 points at least. The exception, of course, being the horizontal and vertical lines. But if that's not the case, we can now use our intercepts to help us with determining those 2 points. So I am going to make the note to you guys. It is advised that you find a third or a fourth point, as well as if the intercepts are not easily graphable, meaning they're kind of gross fractions or decimals that show up in there. So that means if you are setting up your graph for yourself, and let's say one of your intercepts, let's say the y-intercept, is the point 0, 2.5. Okay, well, that's not necessarily the worst fraction that you have showing up in there. We could probably still graph that thing just fine. But if the y-intercept ends up being, let's say, it's 0, 2.1735829, whatever, bunch of stuff after that. That's not really a nice point, shall we say. It's kind of a gross fraction or a decimal. And we may want to find a third or fourth point that's a bit easier to graph at that point in time. But the main idea behind this is now, when we're being asked to find our 2 points, we could find the x and y intercept and use those instead. So yesterday we said we could choose and find any 2 points that work to graph these things. Now we have 2 fairly reliable points that we can always find, the x and the y-intercept. And you are more than welcome to use the intercepts only. You are more than welcome to use an intercept and something else, just something else, but this is now additional options at our disposal to go through and find points and graph these equations. So I'm going to go through 2 examples with this. I'm going to go through example 1, and I'm going to go through example 3 because we have a fraction showing up in here, and I want to show you guys how you can deal with that. So those are our 2 examples, and we're going to go through and graph these things using the y-intercepts. So we'll jump on over to our whiteboard. So move this over here. Okay, so we're going to be graphing these things. So our first equation that we have, y equals 2x plus 5. Oh, sorry, 2x plus 6. Better x here. So it's an actual x, not a weird y. Okay, there we go. So again, we can graph this thing by, we need to find at least 2 points, and now we're going to go through trying to graph this thing using the x and the y intercept, just for the sake of seeing that we can use those and how we would use those to graph these things. So again, just like we did with our previous examples, I'm going to find the y-intercept. Again, it doesn't matter which one you start with. It's your call. And then I'm going to find the x-intercept, and I'm going to graph those 2 points. So just like we were doing with our previous examples, we're just following that process again. Just now have an end game as to why we are going through and doing this. Oops. Y equals 6. So we have the point 0, 0, 6 for our y-intercept. So I have one of my points. Let's find our x-intercept. Again, our x-intercept has a y value of 0. So starting with our general equation, I'm plugging 0 in for y. I'm going to subtract 6 from both sides. Getting negative 6 is equal to 2x. Divide both sides by 2. I'm getting that x is equal to negative 3. So my x-intercept is negative 3. So now I have my 2 points. Let's get an actual box around this thing. So I have my x-intercept and my y-intercept, and those are the 2 points that I'm going to use to graph this thing. They're nice values in the sense of they're not decimals, they're not fractions, and they're nice values at this point in time. So that's what we're going to use to graph this thing. Now again, when we are setting up and creating a graph, we have all those requirements that we need to make sure we have met to do so. points here. So I'm setting up my graph. I have my positive x direction, my positive y direction. I'm going to scale these things. My x-axis I'm scale by 1, so 1, 2, 3, 4, and -4. I'm going to scale my y-axis the exact same way. So I'm going up 1, 2, 3, 4, 5, 6, 7. And 1, 2, part way up, I'm just going to label another one just so I can keep track of myself. 3, 4. So again, I have my axes set up. They are labeled. The positive and negative directions are labeled. And the scaling is clearly defined. So minimum requirements that we need for setting up and creating a graph. Now, we have our 2 points. We have -3, 0, and we have 0, 6. So -3, 0, I'm going to use yellow to graph these things just so it stands out a bit more. I have -3, 0 over here. And then I have the point 0, 6 directly up here. I've plotted those 2 points, and now we can connect those together. And again, you're going to have a straight edge versus me trying to do this freehand. Ugh, terrible. Okay, so something about like that. Oops. And there we have our graph based on just using our 2 intercepts, which we are perfectly okay with doing. Or we can't do that. Yeah. So we'll go through our other example that we have, which is working with, this was example 3. So for example 3, we have been given the equation y equals 1/6 x minus 4. And again, we can solve this thing using the x and the y intercepts. I'm going to start with the y-intercept. And again, for the y-intercept, we always know the x value to be 0. We need to find the y value. So I'm just doing that here. So continuing on the process that I was doing with all the previous examples, just plugging that in accordingly. And I'm finding that the y value is -4. There we go. So let's look at our x-intercept. And again, following the exact same process as we've done with our previous ones. I know my y value to be 0. So that's what I'm going to be doing. I'm just going to be plugging that in for y, and I'm going to solve for x. So I've got that there. I'm adding 4 to both sides. Stop here just a little bit. And now I want to get rid of that 1/6. So if I want to get rid of that, I can multiply both sides of my equation by its reciprocal. So I multiply the left and the right side by 6. That's going to cancel that denominator. 4 times 6, it's going to give me 24. It's a big number here. Okay. And now we have our x value, or our x-intercept and our y-intercept. So now we need to figure out, okay, how are we going to go through and graph these things? So our previous graph we did in yellow. I'm going to do this one for the sake of a different color here. Do this one in green. So we have 2 of our points. Fantastic. And we're going to set this thing up, and we're going to solve for it or graph it accordingly. And again, following all of our procedures for setting this thing up. A bit straighter of a line here. There we go. A little bit better. Okay, so we have our positive y's, we have our positive x, and now we run into the part of, okay, how do we want to scale these things? The main reason we ask that question is, okay, looking at our y-intercept, 0, -4. Okay, so it's not going to be too bad vertically. But horizontally, our x value, or x-intercept, is at 24, 0. That's going to be way, way, way somewhere out here. So what we're going to do is we're going to scale our axes accordingly so we don't have to worry about that as much. So we're going to scale our y-axis by ones. So 1, 2, 3, 4, 5, and so on. 1, 2, 4, 5, and so on. Okay. So my y-axis is scaled by ones. Now I am going to choose to scale my x-axis by sixes. So what it's going to look like is I have 6, 12, 18, 24, 30, 36, and so on and so forth. Same thing in the opposite direction. Again, we can choose how we define and set up and scale our axes accordingly. The two axes can each be scaled differently, but the entire x-axis, positive and negative, needs to have the same scaling. And the entire y-axis needs to have the exact same scaling, but they can be independent and different from one another. So now, graphing our 2 points, our y-intercept was 0, -4. So we find that point, so 0, -4, 1, 2, 3, 4. So 0, -4 down here. And our x-intercept at 24, 0, right over here. Connect those 2 points together. Again, you guys will have a straight edge for doing this, and it'll look better than mine. And there we have our graph. Now, alternatively, it's just an option. If you're looking at these 2 points and saying, okay, well, I like the point 0, -4. It's kind of a nice smaller number that I can work with, fantastic. But I'm not really a fan of using this 24 because it's a larger number. Then you have the option to go and find a third or a fourth point, just like we did previously, that might give you a nicer number closer to being something like this. You can graph that point, and then there's your second point that you can use. So our previously established rules of using any 2 points on the graph still hold true. But now we have the x and the y-intercepts as candidates and options that we can use if we would like to. But our previous rules, our previous methods are still perfectly viable to use if we would like to. There's nothing wrong with that. Or using any of those, I should say. Okay. So this is everything for the 4.3 material. So we'll end our recording here. I'll take any questions that you guys have. We'll go from there.